Good afternoon, and welcome to Facebook Live, YouTube Live, sponsored by Danville's church-based tutorial program. My name is Mrs. Waller, and today we will be talking about antonyms. So let's go to work.
Hey, boys and girls! What's up? It's time for the antonym song. Said it's time for the antonym song. It's time for the antonym song. It's time for the antonym song. Come on.
Antonyms are opposites. Antonyms are opposites. Antonyms are opposites. Opposites are antonyms. I said opposites are antonyms. Antonyms are opposites. Antonyms are opposites. Antonyms are opposites. Opposites are antonyms. Said opposites are antonyms. Tall and short. Cold and hot. Black and white. Up and down. New and old. Antonyms are opposites. Antonyms are opposites. Antonyms are opposites. Opposites are antonyms. Say opposites are antonyms. Antonyms are opposites. Antonyms are opposites. Antonyms are opposites. Opposites are antonyms. Say opposites are antonyms. Like big and small. Open and close. In, out, on, off, night, day. Antonyms are opposites. Antonyms are opposites. Antonyms are opposites. Opposites are antonyms. Opposites are antonyms. Antonyms are opposites. Antonyms are opposites. Antonyms are opposites. Opposites are antonyms. Opposites are antonyms. Over, under, left, right, yes, no, win, lose, run, walk. Antonyms are opposites. Antonyms are opposites. Antonyms are opposites. Opposites are antonyms. I said opposites are antonyms. Antonyms are opposites. Antonyms are opposites. Antonyms are opposites. Said opposites are antonyms. Said opposites are antonyms. Front and back. Top, bottom, happy, sad, fast, slow, inside, outside. Antonyms are opposites. Antonyms are opposites. Antonyms are opposites. And opposites are antonyms. And opposites are antonyms.
Said it's time for the antonym song. 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 Said it's time for the antonym song. It's time for the antonym song. It's time for the antonym song. Come on.
Okay, let's play a game. The object of the game is to help my friend here jump from board to reach the top of the page to find the correct path. I'm going to give you some clues to follow, okay? Number 1, finish. So you want to get the antonym. Finish would be start. Remember, an antonym is the opposite. Low, high. Number 3, right. The opposite is left. Number 4, day. The opposite is night. So see, he's moving right along. Dark. The opposite is light. Number 6 is big. The opposite, small. Number 7, thick. The opposite, thin. Number 8, girl. The opposite, boy. Number 9, fast. The opposite, slow. Number 10, clean. The opposite, dirty. Number 11, hot. The opposite, cold. Number 12, good. The opposite, bad. Number 13, wet. The opposite, dry. Number 14, open. The opposite, closed. Number 15, in. The opposite, out. Number 16, past, opposite, future. Number 17, happy. The opposite, sad. Number 18, near. The opposite, far. Number 19, full. The opposite, empty. Number 20, easy. The opposite, hard. So he's moving right along here. Number 21, long. The opposite, short. 22, new. The opposite, old. Number 23, above, below. Okay, moving right along. We're going up the hill. We're going fast now. Number 24 is top. The opposite is bottom. 25, asleep. The opposite, awake. 26, early. Opposite, late. 27, correct. Opposite, wrong. Number 28, east. Antonym, west. Number 30, first. The antonym, last. Number 31, north. The antonym would be south. Okay. 32, odd. Antonym, even. 33, friend. The antonym, enemy. 34, after. The antonym, before. Number 35, answer. The antonym, question. Number 36, noisy. The antonym, quiet. And number 37, start. The antonym, finish. That's all for today. See you next time.
Good afternoon, everyone. Welcome to Facebook and YouTube Live. Sponsored by the Danville Church-based tutorial program. My name is Mr. Waller, and today we will be dealing with circles. Let's begin. Today in our lesson, we're going to calculate the diameter, we're going to figure out the radius, and we're going to figure out the circumference of this can. Earlier this week, we discussed the radius, we discussed the diameter, and we discussed the circumference. The radius of a circle is the distance from the center of the circle to any point on its circumference. And also the radius is half of the diameter. The diameter of a circle is the distance from one point on a circle through the center to another point on the circle. The diameter of a circle is twice the radius. The circumference of a circle is the distance around the circle, or some may call it its perimeter. The diameter of the can equals 2 5/8 inches. Let's take a look at this. Let's put our ruler on it again. if we actually measured this and it's 2 5/8 from here to here, then half of 2 5/8 will be 1 5/16. So 1 5/16, each one of these marks represent a 1/16 of an inch. So 1, 2, 3, 4, 5. So approximately about right here would be the center of the circle for this can. So when we measure this, anywhere we measure it on the can, it should be about 1 5/16. 1 5/16. Anywhere on the circle, pretty much it'll be 1 5/16. All right. So our radius is 1 5/16. Okay, let's go back to our can. So we know the radius, we draw a line from the 0 over to here is 1 5/16, as you can see. Let me zoom in a little closer. All right, but we know the radius is 1 5/16. Okay, now the diameter, when we measured across earlier, was 2 5/8, and it's still 2 5/8. And anywhere I mark it on my can, that's what the measurement will be. 2 5/8. All right, that is the diameter from one side of the can to the other side. So that's 2 5/8 of an inch. The circumference of a circle is the distance around a circle, or what some people like to call it is its perimeter around the circle. All right, so it's all the way around. So let's write down the word circumference. Circumference. And the formula, I'm going to show you two formulas. C equals 2 times pi times the radius. So another formula is also C equals pi times diameter. All right. Now the reason why those are equal to each other is because, remember, the radius is half the size of the diameter. So if I got 2 times the radius, that's 2 radius, that equals 1 diameter. So if I rewrote this, 2r is equal to the diameter. That's just to let you know that those two are equal, and then both of them have pi in there. So 2r, diameter. That's why the formulas will work the same. So if you know the radius of the circle, then you just put it into your formula, and then you would find the circumference. Or if they give you the answer as the diameter, then you use this formula, pi times diameter. Now pi, you have to know what pi equals. And we're not going to use the full length of pi because it's a very long number. It never ends. So we're going to use 3.14. 3.14. Okay, students, let's calculate the circumference of this can. We're going to use the actual numbers we had and use the formulas. C equals 2 times pi times the radius. And we're just going to plug in the numbers. All right. We're finding the math calculation of what the circumference will be. But when we actually do our measurement, it may not be exactly to the same numbers as our math calculation, but it should be very, very close. All right. So we're going to put in here our 2 times, we can put a dot or we can put an X. And then we got pi, which equals 3.14. We don't put the entire number, we just write a portion of it. 3.14 is pi. And we're not saying pi that you eat, it's pi is pi. Pi. And then our radius, we calculated it to be, when we converted it to an improper fraction, Our radius was 21 over 16. So we write 21 over 16. And then also, you know that 2 over 1 is the same as 2, and 3.14 over 1 is the same as 3.14 written as a fraction. All right, so now we multiply everything across. We got 2 times 3.14, and you put that into your calculator. 2 times 3.14 gives you 6.28 times 21 gives you 131.88. 131.88 or 88 hundredths. And then we multiply 1 times 1 is 1 times 16 gives us 16. All right. And we can figure that out. Do 131.88 divided by 16. And we come up with our circumference to be 8.2425. So that's almost pretty close to 8 1/4 of an inch, because 8.25 equals 8 1/4 of an inch. So that is a little bit less than 8 1/4 of an inch. Okay, so now we're going to do our actual measurement and see. If you were in my math class, you would actually bring your own can to class, and then we would provide you with the tape measure. All right, here's my tape measure. I've put a red mark on the can, so that's where I will start at with my ruler. And we're going to measure it around, and we should be close to 8 1/4 of an inch. And as you can see, it is pretty close to 8 1/4 of an inch. The red mark, everybody see that? 8 1/4. All right. So that was pretty close in our calculations when we measured the can. C equals 8 1/4 of an inch. So actual measurement of the can when we put the ruler around it. And then this was our math calculation, which was 8.2425. But see how close it is to 8 1/4 of an inch? So to refresh, our radius is the distance from the center of the circle to the outer boundary or the circumference of the circle, and which we measured ours earlier, and we got 1 5/16 of an inch. That's the radius. And then our diameter is from one end point to the other end point of the circle, and we came up with 2 5/8 of an inch. And the two formulas that you can use to calculate circumference is C equals 2 times pi times the radius, or C, which is circumference, pi times diameter. All right. And so remember, the circumference is the distance around the circle. Or most people, if you say perimeter, that's an easier word for them. But they use circumference when you're dealing with circles. So it's the distance around the circle. Okay, parents, while you're at home homeschooling your children, this is some great STEM education that you can provide for your children. Simple activity and learning the parts of a circle, and also doing the calculations or the formulas to find the circumference of a circle, to find the diameter, the radius, and so forth. Simple objects that are round circles. I used a can, simple little ruler, and then a measuring ruler that you measure fabric with. So that way you can do the circumference and get pretty close to the actual math numbers. So real life problems, real situations, and also something to have fun with your children. All right. Well, we thank you all that viewed the Facebook Live and YouTube Live. Hopefully you enjoyed learning about circles today. Have a great week.